Hello, I hope this video finds you well. Today we're going to look at a Waterloo CCC problem, specifically J1 from the 2016 tournament selection. So the problem states, each player in a tournament plays 6 games. There are no ties. The tournament director places the players in groups based on the results of games as follows. So if a player wins 5 or 6 games, they are placed in group 1. If a player wins 3 or 4 games, they are placed in group 2. If a player wins 1 or 2 games, they are placed in group 3. And if a player does not win any games, they are eliminated from the tournament. We're going to write a program to determine which group a player is placed in. So our input specifications consist of 6 lines, each with one of 2 possible letters, W or L. Our output specifications is we will output either 1, 2, or 3 to indicate which group, or a -1. And if we scroll down, we can see here's our sample input. And so because this person wins 1, 2, 3, 4 games, it outputs 2 because that is in this range here. Now I'm going to do this 2 ways just to talk about the different ways that I've seen students do this, and because there's some good learning here. So the first thing to point out is this is a J1 problem, and really there's never any lists in this. So the first approach is kind of the standard way I expect students to approach this. So we're going to make a definition, and we're going to call it problem. And we're going to start off by taking 6 inputs. So we're going to say G1, game 1 equals, and what I'm going to do is I'm simply going to duplicate the inputs that they have in the sample here. And then by doing that, I don't have to type the inputs in every time. It's only once I actually get the problem working that I'll go back and I'll change this. And this is a strategy I recommend when you're writing programs and contests because it means you're going to be a little faster. So G6, there we go. So there's our 6 inputs. Okay, oh, got to close that there. So what we need to do is we need to check. So step 1 is we take our inputs. Here's our step 1, take inputs. Now what we need to do for step 2, we need to count if an input is a win or a loss. So we're going to make a variable called W for total wins and L for total losses, and we'll set them both to 0. And we're going to say if G1 is equivalent to a W, then we say win is equal to win plus 1, else loss is equal to loss plus 1. So basically, we are going to, if we find that the first game is a win, then we add 1 to the wins, else we add 1 to the losses. And we have to do that for each input. So we're going to do that now here for game 2. I'm going to change that to 2, and I'm just going to paste this down for each case. And there we go. So we basically have the structure that if the game is a win, we add 1 to win, otherwise we add 1 to the losses, and we do that for every game. So there's game 1, game 2, game 3, game 4, game 5, and game 6. And now that we have that, let's hit enter a bunch of times again. What we're going to do is we want to check what group they're going to be in. So to do this, what we do is we say, we come back, let's actually come back to the problem for a second, and let's just take this part so I don't have to keep going back and forth. So if a player wins 5 or 6 games, they're placed in group 1. So we're going to say if W is equivalent to 5 or W is equivalent to 6, and we're going to then return, we're going to return group 1, so we'll return a 1, elif W is equivalent to 3 or W is equivalent to 4. We're going to return 2 because that means I'm in group 2. Elif W is equivalent to 1 or W is equivalent to 2. And we're going to return, in that case, group 3. And if none of these are successful, basically they don't win any games, we're going to return -1, which indicates that they haven't won anything. And so here's our, said that was step number 3. Step 3, check the group. Now, you'll notice I do this a lot, and again, some people ask me why I do this, especially with these easier problems, because you really don't have to. But I like to put them in functions because it means I can just return the value once I find the answer, which makes the algorithms a little easier to manage as problems get more complicated. Also, as a beginning programmer, doing this is a great way to practice building functions. So what I have to do though to run this is I have to now actually invoke that function. So I'm going to actually print. I'm going to print and then I'm going to invoke the problem, because what has to happen is we're going to run this problem that will return the right answer for us and then print it out. So if I save this now, and we just look, there it is. We're going to say Python 3, CCC, 2016, and I end up in group 2. So let's check. If we come back to this problem here, yep, we're supposed to be in group 2. If we're all losses, we're supposed to be in -1. So let's come up here and let's put all losses, just to quickly check this. Loss, 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 loss. We're going to save this. We'll come back into here and we'll run this. -1. What was the other one? Let's check the other case. If we win 5 or 6 games. So let's make all of these wins. So win, 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 win. I'm going to save this. I should get a group 1, and there's my group 1. Now I'm not going to do exhausting testing here. I'm just going to do a couple cases. And that's it. But if I was to upload this, I would have to change these to inputs before I actually upload it into the system. So we're going to make this input, make this input, we're going to make this input, we're going to make this input. And that's it. So now when it uploads into the system in the CCC, it will automatically take the inputs that are used in test cases and off it goes. Now, let me show you a different way to approach this. So this problem is set up in a way such that there are 6 inputs, so you can easily hard code these. And as the problems get more complicated, they'll start doing situations where instead of 6 games, you're going to play 600 games. And you're not going to be able to hard code that. And that's where loops come in useful. So what I'm going to do is I'm going to make a definition here. We're going to call it problem, and we're going to call it the alternate solution. So I'm going to say alt. And instead of actually saying individual variables, I'm going to make a list called games, and I'm going to make it equal to, I'm going to give it 6 things. So for now, we're just going to put when, we're just going to put 6 things in here. Actually, let's do it this way. Let's go games, and now I'm going to say games.append, and I'm going to take an input from the user. So basically, I'm going to take an input from the user, and I'm going to put it on that list, and I'm going to do that 6 times. So that's 1, 2, 3, 4, 5, 6. So what I've done is I've taken the input and I've appended that to the list 6 times. And so now I have the exact same situation here, which I have down here, except that is all contained within this list. And the beautiful thing is about lists is that I can loop through them. So I'm going to make my wins equal to 0 and my losses equal to 0. And I'm going to say for I in range, and I'm going to go from 0 to the length of games. So I'm going to look at each element in the list and increment by 1 each time. Now I know that there's lots of different ways to write these in shorthand, but again, I like to write out the long format when I'm working with students because I find it translates really well to other languages. And what do I want to do in here? Well, I want to say if games at I is equivalent to a win, then what we're going to do is we're going to say wins are equal to win plus 1, else loss is equal to loss plus 1. So basically, if we find a win in the element, we add 1 to win, otherwise we add 1 to loss. And then once we're outside that loop, what we're going to do is we're going to come down here, we'll take the same logic here, and we're just going to paste it there. So essentially, if the person, once we've counted the wins and losses, we just check the number of wins and losses and return the appropriate value. So if I come in here, problem, alt, and I save this, oh, I got to print it out, because remember that's being printed to the screen, and actually we'll come down here and we'll comment this other one out. So let's give this a save, let's come in here and give this a run. Oh, how many people caught that when I was typing? Forgot the colon there, right there. We'll give this another go, there it goes, so it's waiting for me input. So if I put win, 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 if I win every time, I get 1, I'm in group 1. If I lose every time, remember it has to be capitals, I get -1. If I win, 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 lose, 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 I get a 2. And let's just confirm that. Group 2 is for a situation where we win 3 or 4 games, and that's it. So either approach is fine, but what I like to highlight to students is that this is actually how this problem is expecting you to do it. But the larger idea here is that in this case where we have we have a fixed number of inputs, we can hard code. Well, we have a fixed number of inputs and a small number of inputs. We can hard code each situation. But if I can easily change this now to take 600 inputs, and it can still calculate the same way. I hope this video helped, and if you have any questions, please don't hesitate to ask. Take care.